So in this video, we're going to be doing some practice problems on radicals. We're going to simplify radicals, rationalize some things, and then solve radical expressions, it looks like, okay? So let's dive right in. As always, I recommend you try the problems first yourself by just pausing the video and then unpause it to see the answer and see how I thought through the problems, how I worked through them, okay? Number one, which of the following is equal to a to the negative half power? Well, first of all, negative exponent, you can rewrite it as in the bottom, but make it positive, so bottom of a fraction. So it'll be a to the half. It's one of the properties. Half power is the same thing as square root. Okay, so answer is B. Simple as that. By the way, the properties of exponents are the exact same as properties of radicals. So if you learn them separately, properties of radicals and properties of exponents, you'll realize they're actually the same because you can write a radical as an exponent. So all the rules apply. Okay? Which of the following is equal to this? This looks like you just need to rationalize it because really no one cares in the real world. But when you first learn it, they don't like having radicals in the denominator. So to rationalize it, to not have it, you have to, or to not have a radical at the bottom, you have to rationalize it. So how do we rationalize something like this? Well, we do the conjugate. Okay, so instead of a minus, it'll be a plus. Okay? So we would have 3 plus 2 root 2 on the top. Okay, and what's on the bottom? This is a difference of 2 squares, so that's where that formula comes in hand. It'll be 9 minus 4 times 2, which is 8, which is 1 on the bottom, so 3 plus 2 root 2. Answer C. Next, if this guy cubed is minus 64, what is the value of x? Okay, so to solve for x, we can cube root both sides first. So it'll be x plus 1 is the cube root of minus 64. What's cube root of minus 64? Well, negative 4 cubed would give us minus 64. No plus or minus if it's a cube root, okay? So that x is minus 5. Okay, it should be easy. I'm pretty sure I learned all this in 7th grade in the States, so these should be easy. Which of the following is equal to this guy? Okay, we've got to simplify this. So root 8, well 8 is 4 times 2, so I can write it as 2 root 2. Okay, this 18 is 9 times 2, so I can write it as 3 root 2. And this is 16 times 2, 32. So it'll be 4 root 2. Okay, 2 root 2s plus 3 root 2s, that's 5 root 2s. And then minus 4 root 2s, that is 1 root 2. Answer is A. Which of the following is equal to this? Okay, so let's FOIL it out. It'll be 2 minus root 3 plus 2 root 3 minus 3. Okay, so this is minus 1 minus root 3. Answer C. Actually, did I do this right? 2 minus root 3 plus root 3. So this should be a plus. So it should not be that. And it should be D then. Okay, my bad for that careless mistake. Which of the following is equal to b to the 5/3 power? Okay, there's 2 ways to represent this. You should have learned this as one of the properties. So you can write it like this: b to the 1/3 to the 5th power. Okay, because by properties of exponents, you would multiply those two and get back 5/3. What is b to the 1/3 power? That's cube root of b to the 5th. That's one form. The other form is, so let's jump to the cube root of b, but then you're going to 5th power what's inside the radical. Okay? So it looks like we need to approach it like this, though, because we got to simplify. It would be, well, b to the fifth is b cubed times b squared, is it not? What's cube root of b cubed? That's just 1. Sorry, that's just not 1. That's b. So it'll be b times cube root of b squared. Okay? So that is choice D. So you could have did it like this. Or you could have went by the choices. This is b to the first power times b to the half power. So you add the two, that would be 3 halves. That's clearly not 5/3. Cross that out. This is b to the first power times, this is, we're square rooting b to the 1/3, so this is actually b to the 1/6 power. That's clearly not 5/3. Cross that out. This is b to the first power times b to the 1/3 power. This is 4/3 power, if we combine, not that. This is b, and b to the, that is 2 over 3. So that's 5/3. 1 plus 2/3, that's 5/3. So you can do it like this as well. Okay, that's for this set. Let's move on to the next set as well. Solving radical equations. Okay, what's the solution set to the equation above? Okay, so by the way, when you solve radical equations, sometimes you have extraneous solutions, which I did a video on this before, so you can go check that out. But basically, you have to plug back in your values of x to see if your equations are actually true with them. Okay, what's the solution set to this? Well, let's isolate the radical. So it would be 3 is square root of 2x plus 3. So 9 is 2x plus 3 if I square both sides. So then this is 6 is 2x, x is 3. Answer is B. Okay. What is the solution set of the equation above? Okay. So let's square both sides. Minus 3x plus 4 is 49. Okay. So minus 3x is 45. X is 15. Minus 15, sorry. Answer is A. I was checking, that was actually minus, which it is. Okay. What's the solution set to the equation above? Okay, so here, there's probably going to be an extraneous solution. I can tell because here, they were just saying the radical is equal to some constant. Here, it's equal to another function of x. Well, technically, a constant is a function of x, but there's explicitly another x there. So that's why I'm already guessing there's probably going to be an extraneous solution. And looking at the choices, there probably is as well. Let's square both sides. So x plus 18 is, this is where that formula comes into play. X squared minus 4x plus 4. Okay? Let's solve for x. 0 is x squared minus 5x. This is what? 18 minus 4, that is minus 14. Sorry, 4 minus 18 is minus 14. Okay, so 0 is, if you factor this, would be x minus 7, x plus 2. So it looks like x is 7 and x is minus 2. So as I said, we got to check if there's an extraneous solution. For example, if x is negative 2, we have negative 4 on the right-hand side. But when you square root something, can it ever be negative? You can't. Cross that one out. How about x is 7? It should work. That's 25 under the square root, so that's 5. 7 minus 2, that's 5. So the only answer is x is 7. Solution set to this, square both sides again. 5x minus 12 is 9 times 2. So that is 18. So 5x is, that's 30. X is 6, right? You should be quick. A is square root 3. Square root of the sky is 1/3 a. What is the value of x? Okay, so can we just plug this into right there? Okay, square both sides. 2 minus 3x is, if I square both sides, this would be 3 over 9. Okay, let's multiply 9 on both sides to get rid of this fraction. Okay, so that's 18 minus 27x is 3. Okay? So 27x is, that is what? 15. So x is 15 over 27, which I can write as 5 over 9. That's the answer. Okay? Last one. K equals 8 minus root 2. Cube root of x minus k is minus 2. What is the value of x squared? Okay, so I'm thinking we just start from here until we get to x squared. Let's manipulate. Okay, so let's cube both sides first to get rid of that cube root. So it'll be x minus k is minus 2 cubed. That is minus 8. Okay, and we know what k is. So let's move it to the other side first. It'll be minus 8 plus k. Okay, so let's plug it in now. Minus 8 plus 8 minus root 2. That is minus root 2. So x is minus root 2. But we want x squared. Imagine, so first of all, on the SAT again, you probably can't punch in, bubble in a negative number, at least back then. So this is not the answer, clearly. And how would you bubble in square root of 2 if you're not allowed to calculate it? You can't round it, okay? Unless you memorize this. It's like 1.4 or something, if I remember correctly. I don't remember, see? So let's solve for the actual problem, x squared. So let's square both sides. That's 2. Okay? And that's it. So hopefully you saw that these are not tricky at all. Just you got to be careful only for the ones with extraneous solutions. You got to check. Otherwise, it should be straightforward, hopefully. If not, there's lots of resources online for you to get more practice. All right? As always, please like and subscribe if you found this helpful, even if you just got some good practice out of this. And please look out for the next video as well, in which we'll talk about complex numbers, it looks like.